I would like to welcome our next team to the table. We're really looking forward to getting to know you guys, but I think let's start off with why don't you introduce yourselves? Tell us your name, let me know what university you're representing, and what degree program that you're in right now.
I'm Frankie, and our team is from George Fox University. We are all going to be seniors at the university this coming school year, and I'm studying biomedical engineering.
My name's Zach Heath, and I'm studying computer science.
I am Luke, and I'm also studying computer science at George Fox.
Excellent. So, what we really want to know is what's brought you here? What's your team name, and what role do each team member have within the project?
I guess as a computer science major, I'm on the part of the team that helps manage the software side and controlling the printer and the pumps and making sure the GUI can do all that stuff.
Yes, along with that, since I'm also studying computer science, been mainly working on the software parts of the project, including the website and the server, and running all the code in the back.
I have been supporting throughout the process of making our product, I've been supporting with the parts that we 3D printed. So they're typically like supporting parts. They're not always necessarily a part of the main function, but they help organize or, like, for example, store components or guide tubing into the right place. And on behalf of our other members, we have Kyler Diefenbaugh, who is also a computer science major and who's also been supporting with the software and website making. We also have Josh Bakos, who is a biomedical engineering student, and McKenna Taylor, who is a mechanical engineering student. And so I have been in the process, we worked together to print those 3D printed parts, those accessory components, and then as well as do part of the research regarding the background of in the field of biology, which is where the problem that we're trying to address is occurring.
Oh, wow, it sounds like you guys have worked really hard to make sure that uh, everyone is well rounded and there's a lot of support, and you're really focused on each one of your specialties. That's so cool. But let's hear more about the project. Tell me what you're working on. What is this innovation?
Our team name is A.M.E.N. It stands for Automated Media Exchange Network. And so our product or our device is to assist biologists when they are replacing media in cell cultures. Biologists, they culture cells in order, and that step alone is definitely like extremely foundational in any research that they're doing. It's where they're able to like test medicine, drugs, or even just study the pathology of a disease is within a cell culture. And so part of maintaining the cultures is replacing the media that is within the cultured dish. And that is often a tedious and time consuming process. It's very manual. You take one pipette and you go in your multiple plate over and over again until you're done. And you also have to do that twice through because you're removing media and replacing media. So our device is automating that process. And Zach and Luke can probably add on what I haven't discussed.
I'm not sure how much there is to add, but on the software side, we're using a Raspberry Pi to control the printer as well as controlling the pumps and to control the everything is run off the Pi and everything is connected to the Pi. As for our how we move the head around, it's just a 3D printer to get that free X, Y, Z movement, and that allows us to focus more on other things like getting the media exchange, getting contamination.
That's really cool. It sounds like you've worked very hard to come up with a solution that not only could save a lot of labor time, but actually, like, think about it like carpal tunnel and all kinds of other random things. So it's a health, wellness, and efficiency project that's truly inspirational. I'm really curious, where did the idea come from? What was the genus of this? How did you guys start down this path?
This project was created as a result of the servant engineering course or like program that we have at our school, where all juniors within engineering computer science are assigned to teams, and they have a professor as like a mentor and advisor that kind of guides them along. And at least in our case, our professor actually came up with the concept of a device that could automatically exchange media and help push along the cell culturing process and make that more hands off and faster and more efficient. So that's where the original concept came from. And the idea of using the 3D printer came from consulting with some electrical engineering professors at our school who figured out that was a really cheap and efficient way to get very precise X, Y, and Z movement, which is exactly what we needed for the project.
To add on, the idea of an automated media exchange device has been like worked on and developed in other places and but in other circumstances where there is more funding. And so I think the special part about our project is that this is mainly to serve professors that are at our school, which include our faculty advisor, Dr. Abraham King, as well as the other biology faculty who, in their summer research or in their um, semester, in their during their semester during with their classes, they deal with culturing cells and replacing the media pretty often.
That is a great path to find inspiration from. Tell me a little bit more about like who this innovation will serve, like what's your target market, who's going to be buying this?
I think the target audience for this device would be small research firms that need some cell culturing automated a little bit, but they don't have the funding to buy the big expensive equipment that is already on the market that would cost them several thousands of dollars over our system, which would only cost them a 3D printer, a Pi, and some other stuff that would be in our kit, I guess. And yeah, it could also be good for educational uses if they just have a small bio department and need a little bit.
Can you share a little bit more about why something like this is so important to pursue?
I think that there are a lot of potential, like, not only by using our device, the biologists themselves who is utilizing the device, they are saving time in their research. And it has a lot of like exciting implications to automate this media exchange because oftentimes in this research that we were focusing on, like this biological research, oftentimes cell culturing is foundational or it's one of the preliminary steps before the true gritty research actually begins. And so, by assisting in this part of the process for research with this kind of innovation, hopefully that'll like speed up and further more like either biological discoveries or developments in research.
That's a very noble goal, and I really hope to see it come to fruition for sure. Thank you guys for sharing so much about your project. Now, I kind of want to learn a little bit about your journey. As you've gone through this process, I know you've been working on this for quite some time, what are some insights that you've learned about yourself about what it's like to be an innovator?
I think the most important thing for innovation and stuff is utilizing your friends and just asking them for what they know, and because that has been very helpful, at least for what I've been doing. Because I have a friend who's a computer engineer and knows a lot about that, and he's helped me design the PCB for our for our project that wouldn't brick the pie like the first one did.
That's so very true. No one builds anything by themselves, and relying on not only your teammates but the network that you have is that's how the game is played. So I think that's great that you've learned that early on in this process.
I think oftentimes in our engineering education or STEM education, like or at least I hear a lot, reiterate, like go through it again, figure out what's wrong, and then try and address that. And then you keep going and you try it again and again. And that does require a lot of perseverance. And so I think what I'm thankful about or grateful for in this project is actually getting to experience that process because it's very different from just knowing or hearing about the many iterations that happen in other engineering projects or other projects that you do. But being able to experience that myself has been definitely a great opportunity for growth and has forced me, in a good way, to learn a lot more than I would otherwise, like without having done this project.
Throughout the process of becoming innovators, inventors, entrepreneurs, I think it's wonderful that you have picked up on those processes that are so crucial to how you build a project and build a startup. I love that you are relying on those around you, seeing the value that others can give to you. But, I want to know, what have you learned about yourself while you've been participating in InventOR again?
What I have learned about myself is that I enjoy seeing the big picture and working backwards from there. My It's been fun to learn a little bit more about how my brain works in addressing like this project and this problem that we want to address. So I think I've learned the value of both sides. So I myself am a big picture thinker, but also being detail oriented is important. So I think I've been able a little bit more to step into both of those roles in the process of completing this project. But I definitely have to say that I've learned how much I enjoy looking at the big picture and seeing and working backwards from there and seeing the elements that we can work on now, having the big picture and the end goal in mind.
That's excellent. I'm thrilled to hear that. As you're getting ready to get your final presentation up and running and getting your prototype for the booth, what are you most looking forward to about meeting the judges and presenting your idea?
One thing to look forward to in presenting our product is, I think, being able to share about this problem that we have, and I guess, or the problem that exists in this process of like biological research that we want to address. So I think we're looking forward to shedding a little bit more light on that and bringing out or being able to explain the necessity or the benefits of having a solution that is more accessible, that would be able to serve small laboratories versus like big industrialized companies.
That's excellent. This is such a wonderful, noble pursuit, and I think you guys are going to do great in the finals. And I cannot wait to see your final prototype and hear your pitch. I'm really looking forward to it. I wish you the best of luck on the 24th and over the coming weeks. Congratulations for making it this far. Thanks for being with us.